Welcome to Aftermath Mathematics.
Hey guys, I am Michael Gonzalez and you're watching the Aftermath.
Hi, my name is McLeod. You are watching the Aftermath.
Darth Padayon and you're watching the Aftermath.
Hi, I'm Leo Da Vinci. You're watching the Aftermath. Hi, I'm Steve Seagull, and you're watching the Aftermath.
Hi, I'm Vince and you're watching the Aftermath.
Hi, this is Glenn, and you're watching the Aftermath.
Hi, this is Trisha Jin and you're watching Aftermath.
Hello, welcome to Aftermath Mathematics. On today's episode, I'd like to tackle another type of probability: mutually inclusive and mutually exclusive events. I'm going to talk about the differences between two different terms, give you a few common examples of both. At the end of this video, Aftermath Mathematics expects you to master and analyze a situation. On previous episodes, our associates from other groups tackled about simple probability and compound events. So, let's move on. So, the points or the specific terms we should consider to learn in this episode are the following. Number 1, the additional rule. Number 2, outcomes. Number 3, experiment. Number 4, probability. And lastly, mutually inclusive events and mutually exclusive events. Remember that in previous videos of our other associates, probability is presented by the number of ways an experiment can happen, divided by the total number of outcomes in an event. An experiment is the process of how a person does the event, and the outcomes are the possible results which may be presented in an event. Recall our channel's previous videos are simple events and compound events are tackled. Simple probability tackles one event. Compound probability tackles multiple events at the same time. When determining the probability of two different events, we take a look at two more terms: mutually inclusive and mutually exclusive. Two events that cannot occur at the same time are mutually exclusive. They have no common outcomes, always different outcome. Such events are so that when one happens, it prevents the second from happening at all. A very common example of this is flipping a coin. It is exclusive because you can't have it landing on both heads or tails simultaneously. However, mutually inclusive events can happen at the same time. For example, you want to roll 2 dice. That event that is present on outcome of a number less than 6 and you want to pick an even number can still happen. Recall what I said, that event is mutually exclusive in two events cannot happen at the same time. Let me give you an example. Pick a number less than 5 and another greater than 5. This is an exclusive event because they can't both happen at the same time. This is an example of mutually inclusive events. This is when you pick a number from 1 to 10 and that is less than 4 and an even number. Let A be 1, 2, 3 is equal to 3 over 10. And B is equal to 2, 4, 6, 8. Now you know the basics of mutually inclusive and inclusive events. Now let me give you a one-item quiz. Jack is a student in UP Manila. He noticed that a lot of his students in his math class were also in his chemistry class. There are 60 students in his class, 28 students in his math class, 32 students in his chemistry class, and 15 students in both classes. He decided to calculate what the probability was of selecting a student at a random who was either in his math class or his chemistry class, but not both. Draw a Venn diagram and help Jack with his calculation. After answering, post your answers at the comment sections below. Please like and subscribe our channel, The Aftermath, and thank you for watching.